Recording is on.
We'll start our lesson. This is lecture 2 in Higher Mathematics 2 course. We call the theme Limits and Continuity in Higher Dimensions. Because we are studying functions of several variables, more than one variable, functions of two variables, three variables, so we will also have to introduce limits and continuity in several variables, which is in higher dimensions, more than one dimension. To start from the definition, we say that a function f of x, this is our function, the function f of x, approaches the limit L as x and y approach x0 and y0, and y limit xy approach x0, y0, the function f of x approach the limit L. In function of single variable, we have the similar notation, which is limit x tends to x0, f of x approach to L. But now we have two variables, x and y. There are two variables in our case now. So the both variables should approach any number, should approach to its limit. And then we can find the limit of the function f. And if for every number epsilon greater than 0, which is epsilon positive, there exists a corresponding number, delta positive, such that for all x and y in the domain of f, these conditions holds, where f of x, y minus L, when we take the absolute value of this one, and it should be smaller than epsilon, and this expression should be between 0 and delta. We try to understand this with the function of single variable when we studied Higher Mathematics 1 course. But now it's just expanded with the second variable, which is y. It's almost similar, almost same, except we have y here, and we have y here also. In this figure, we can check this one. In the function of single variables, the x, and we had just x, and we took x from the number line, like this one, it was x, and we took any number x. But when we are approaching functions of several variables, for example, two variables, we have a region, this kind of, with learned this in the first lecture, we have a region. So this is the point x and y. If I take for the function of single variable here, x1, and for the function of double variables, with two variables, I can choose a point from this coordinate plane, from the coordinate plane. So it will have its x and it will have its y. So this is the point. And this point should approach to the x0, y0, which is this black point. This blue point should approach to the black point. And when it's approached in this delta radius, the value of function should approach to the number L. The value of function we have to choose for this number line, because it doesn't matter if function has one variable, two, three, or etc. But the value of function will be a number, any kind of number. So this number should approach to number L. So this is the formal definition of function of double variable. For example, as for functions of single variable, it can be shown that limit x and y when x and y approach to x0, y0. So here it's x. What is this? This is our function. So it says now we have f of xy equals to x. This is our function. Function is just x. We don't have y. So if we have the function x, it says put instead of x, x0, put instead of y, y0. So I just have x here. Instead of x, I put x0. So I got the answer x0. So this is the answer x0. In the second case, limit x and y approach to x0, y0. Our our function now, f of xy is y. We don't have x in this case. So just put instead of y, y0. So the answer is y0. In the third case, we have here limit xy tends to x0, y0, and the function is k, f of xy equals to k. K is any constant number. So if you look carefully here, we don't have x, we don't have y in the function. So the answer remains the same as k. When we started to learn functions of single variable and we tried to find their limit when the function is any number or a constant number, we had similar examples. We've tried to solve that. For example, limit x tends to like 7, but the function is 13. What is the answer for this one? Can you see this green text, green expression here?
Yes, yes.
What is the answer for this one? Limit x tends to 7, the function is 13. It is from the previous course, Higher Mathematics 1. So what is the answer? What do you
20?
think? Yeah, 13. It's 13. No, it's 13. Not 7. Our function is 13, but it says instead of x, put 7. Do we have x here? Do we have x? No, we don't have x here. So the answer will be 13.
Yes.
And this one is also similar. For example, I can write one more example. Limit z tends to z0. Function is 13x. What is the answer?
Uh, 13 or only x?
13x. 13x. So
13x. Yeah.
this question says that instead of z, put z0. Instead of z, put z0. But do we have z here? No, we don't have. So the answer will be this 13x, this expression itself. We don't have z here. If we had z here, for example, xz, it will be xz0. If we had, but we didn't have, first of all, so it was 13x. With the functions of several variables, like double variable, like this one, x and y, or triple variables, x, y, z, or other functions, these rules are acceptable. So it will remain the same, the similar rules. Just we have like one more variable or two more variables. Ko'p o'zgaruvchi funksiyalarda ham xuddi shu qoidalar ishlaydi, faqat mana bu o'zgaruvchilar soni ortib qolgan. Shuning uchun ba'zi bir qoidalar kengayishi mumkin. Mana bu ikkinchi o'zgaruvchiga degan joylari kelib qolishi mumkin. Lekin umumiy olganda bir xil ishlaydi. Limit hisoblaganimizda agar soddalashtirish kerak bo'lmasa, oddiyroq misol bo'ladigan bo'lsa, irratsionaldan qutqarish yoki boshqa bo'lmasa, unda x bilan y ni mana bu berilgan ifodani o'rniga qo'yamiz. X bilan y mana bu x nol y nol intilganda desa, demak funksiyadan qaraymiz, berilgan funksiyani formulasidan. Formulasida x bo'lsa, x nol x nol yoki x nol o'rniga raqam bersa, raqamni qo'yamiz. Bo'lsa shuni, agar yo'q bo'lsa, demak o'zini ko'chirib yozaveramiz. So here the rules about the calculating limits. The theorem 1, properties of limits of functions of two variables. The following rules hold if L, M, and K are real numbers. L, M, and K are real numbers. And the limit of f of x when xy tends to x0, y0 is L. And the limit of g of x when xy tends to x0, y0 is M. We had these rules. There were 7 rules in the previous course, Higher Mathematics 1, for the function of single variable. Now we're extending this rule for the function of double variables, for the function of two variables. For example, the first rule, sum rule, it says limit xy tends to x0, y0. And independent of this, we have f of xy plus g of xy.
Mm-hmm.
So how to calculate the limit of the sum? We need to know the each limit. So what is the limit of xy, f of xy, when xy tends to x0, y0? So first of all, we have to find the limit of this one. What is the limit of this one when xy tends to x0, y0?
Mm-hmm.
We know this, it's L, here
X.
it's given, limit x, it's L,
Mm-hmm.
so
L.
we wrote
Yeah.
here L, then plus,
Mm-hmm.
what is the limit of this one, second expression, when xy tends to x0,
M.
y0? It's M,
M.
it's given here, so plus M. So this is the
M.
answer. For example, if I have limit xy tends to, mm, okay, not the x0, y0, let me write here like 2 and 3, and I have some functions here. For example, f of xy, it's some kind of function. And if this is equals to 7, and if I have another one, let me write here, limit xy tends to 3, 2 and 3, g of xy equals to 3. So this expression, the first rule says limit xy tends to x0, sorry, not x0, now it is now 2 and 3, 2 and 3, f of xy plus g of xy will be 3 plus 7. 7 plus 3. 7 plus
It's
3,
10.
and it will be 10. Yeah, rule says about this one,
It's 10.
sum rule.
Yeah.
Next one is difference rule. Difference rule.
Mm-hmm.
It's almost similar, but we have, instead of plus, the minus sign,
Yes.
subtraction, minus sign. We know already what is
Uh-huh.
the f of xy's limit when xy tends to x0, y0. It's L, and we also know the limit of g of xy
Mm-hmm.
when xy tends to x0, y0. It's m. So the answer will be L minus m, this one. And here we
Mm-hmm.
have the constant multiple rule. Constant multiple rule. The question says limit xy tends to the third rule I'm talking about. Limit of xy tends to x0, y0 for the function k times f of xy. So it's k times f of xy. So we have here k itself.
Mm-hmm.
When calculating this, first of all, we have to write k because it's a constant number, and times f of xy's limit. The limit is L. So first of all, we have to write the constant number and
Mm-hmm.
times the limit. And one more rule, which is product rule. Product rule. Limit of product f times g when xy tends to x0, y0 is L times n. L times n, because f of xy is, in our case, limit is L, and g of xy's limit is n. So
Mm-hmm.
the answer will be L times n in this case.
Can, uh-huh. Can you give an example for the third rule, constant multiple rule? Can you give an example for this? For the third one, constant
Okay,
multiple rule.
right, constant
Mm-hmm.
multiple. Okay, for example, we have a limit xy tends to 2 and 3, and function I think it's better to write like
Mm-hmm.
x squared times y. So can you calculate this limit? This one on the right side, dark green. X tends to number 2, Y tends to number 3.
It's x squared.
Here, x squared is number 2. We have to, so 2 squared times, instead of Y, I have to write which number? 3. Okay.
Y is
2
third.
squared is 4.
Yes,
2
3.
times 3 is 4 times 3 is 12, right?
12.
It is clear? Okay. Now, according to the constant multiple rule,
Yes,
which
yes.
is third rule in this case, we may have this kind of example. Limit x and y tends to number 2 and 3, and 13 times x squared y. Can you calculate this? Yeah,
Yes.
sure.
Okay.
According to the third
If you
rule,
put
constant
the 2.
multiple rule, according to the third rule, which is constant multiple, I have to write 13 first here, 13 times, and then I have to calculate the
Yes.
limit, which is x squared y, when xy tends to 2 and 3. But I already have this
12.
one, it's 12 in my case. 13
12.
times 12.
Uh-huh.
It will be how much? 144, 144 plus 12, 156,
54.
right?
154, yeah?
156. No, 56. Because
Okay.
12 times 12 is 144, and plus one more 12.
Yes.
Plus
Yes, yes,
one
yes.
5. This, I've calculated this one using the third rule, which is constant multiple rule. And in the fourth one, which is product rule, it's similar.
Okay.
Because instead of this 13, I will have another function, and I have to multiply both of them together. I will get the
Okay.
final limit here. We have some more rules. Quotient rule. Quotient. Yani nisbat koydası. Kasır olabilecek. It's quotient rule.
Uh-huh.
Let's start with the example. Limit x, y tends to 1 and 3. X squared y again. So how much this one?
Um, 3.
This one is 1, second one is
1,
3.
2, and 3. Answer is 3.
Yes, correct. Okay, we have one example here. Limit x, y tends to 1 and 3 again. We have to find another
It's also
function
3.
here.
Yes, it's also
Yeah,
3.
no, not yet.
And the general answer is
Number
1.
the function is approaching. No, I didn't write the function yet. X cubed, y cubed.
Yes.
So x cubed, which is 1 cubed times y cubed. 3 cubed. So the answer is 1 cubed is 1
It's
times 3
9.
is 27.
No, it's 9.
No,
27.
it's
Yeah, yeah,
27.
yeah.
No, just this one.
27.
So 27. Now, we have to use quotient rule for the next example. Next example, I want to write here limit x, y tends to 1 and 3, and I have quotient here. Upper part is x squared y, in the denominator x cubed times y cubed. We have two ways to calculate this function.
It's a
First of all,
third
we
over
can simplify
27.
it if we can. Yeah, we can simplify it.
Yeah.
you can think about it if you want, but if you don't want to simplify or it's hard to simplify, just use the quotient rule, which is given with number 5. So
Mm-hmm.
do we know the limit of f of xy, which is this one? We have to know the limit of the numerator x squared y is 3. Just now we've calculated, and limit of the
3,
denominator
yeah.
is
And 27.
yeah, that's right. Now we can simplify this. It will give us 1 over 9.
1 over
Okay?
1 over 9.
Yeah, it's 1 over 9. This exercise we've calculated using quotient rule, which is given with number 5. And I'll tell you that you have to be careful
Mm-hmm.
while using this rule because the n should not be 0. N should not be equal to 0.
Yes, yes, yes.
Because in the denominator, we cannot divide by 0.
Uh-huh.
Because of this, n should not be 0. Pay attention to
Yes,
this
yes.
part while solving exercise
We
using
have to,
exactly
yeah,
this
we have
way.
to simplify this one, yeah?
Yeah, if we have this kind of expression, we have to simplify or like try to rationalize if it's irrational, try to rationalize and then uh, we can fix it.
Yes,
We
yes.
can find its limit. Okay.
Mm-hmm.
Next one is power rule. Power rule. Limit x y tends to x 0 y 0 f of x y's n's power will be equal to L's n's power. Now we have this expression. The first example, I'll try to use that one.
3.
Limit
Mm-hmm.
x y, sorry, it's comma, tends to 1 and 3 x squared y to the 4. And this one will be limit
Mm-hmm.
x y tends to 1 and 3 and x to the 2 times 4 is 8 times y to the 4.
Uh-huh.
You can calculate this one by plugging in numbers 1 instead of x and 3 instead of y. Or you can use this rule.
Uh-huh.
You can use this rule also. Without this one, if you use that rule, you will not need this. You will not need this one. If you use the rule, you
Mm-hmm.
have to write here, you know the limit, it's 3, so the answer is 3 to the 4th, 81. But you also can use like
Mm-hmm.
by finding its power, x to the 8 and y to the 4, and plugging in 1 here and 3 here. The answer remains the same. It depends to the situation which you are solving the example. Right? You have to look to the example and find which is the better way, which is better to calculate. And finally, the rule number 7, root rule.
Root rule.
In this
Yeah.
class, root rule. It's similar with the power rule. In the power
Mm-hmm.
rule, we have the number here. In the root rule, we have number here. And
Yeah.
so we have limit xy tends to x0, y0, the function f of xy under the root with n's power. So we can, if we know the limit of f of xy, we can write this one. And from this, I can write 1 over n. Both of same, both of n. But pay attention, be careful. N is a positive, no, there is extra p. N is a positive integer,
Uh-huh.
and if n is given, we assume that L is positive because we cannot find the negative numbers square root. If n is, for example, if n is number
Yes,
3,
yes, yes.
we would have to add it here, so minus 3. So we don't know this one. Or if n is number 4, 4 is root of minus
Yeah.
16. So we don't know this one. It's not defined. But if n is number
Mm-hmm.
3, it's okay to have third root of negative 27. It's okay. But when n is even, when n is even, agar juft bo'lsa, demak o'zining ichida narsa manfiy bo'lmaslik kerak. Manfiy bo'lsa uni hisoblamaymiz, uni bilamiz. Mana shu qoidani aytib ketyapti bu yerda. Okay, one example for this one. Limit xy tends to 1 and 3, and this function x cubed y cubed on the third root, okay, equals to, we know how to calculate, we know the limit of this expression, it was 27, so cube root of 27. So this gives us 3.
Yes.
Is this clear? Okay,
Yes.
In this example, we can combine the 3 simple results following the limit definition with the results in theorem 1 to calculate the limits. We simply substitute the x and y values of the point being approached into the functional expression to find the limiting value. Okay, this is a little bit big example, but it's not terrible. It's super easy. It's super easy. It says limit x and y tends to 0 and 1. And the function is this one, this quotient. How to calculate this? Just plug in numbers. Instead of x, plug in 0. Instead of y, plug in 1. The x here, x is 0. And x 0 here, is 0. Y is here, 1 plus 3.
It's 1.
X here is here, 0. Y is here, is 1. 5. 5 is itself. It's constant multiple root. What is the constant multiple root? It was k in the root. So 0 is 5 itself, and then x 0 here, and then y 1, and then again y is this one. So now we'll see this way. 0 times 1 is 0, 0 minus 0, 0 plus 3. So we got 3. 0, 0, 1. 3 over negative 1 gives us negative 3.
3.
Okay, the next example says limit xy tends to 3 and negative 4. So it says x tends to 3 and the y tends to negative 4.
Oh, yeah.
So the function is square root of x squared plus y squared. X squared. X is 3, so 3 squared plus y squared, negative 4 squared. 3 squared is 9 plus negative 4 squared is 16. 9 plus 16 gives us 25. Square root of 25, it's 5.
It's 5. Yeah.
Yeah. We have done with this first example. And the second example says, find the limit when x and y tends to 0 and 0. Both tends to 0. If we plug in instead of x 0 and instead of y this 0, I will get here 0 minus 0 squared minus 0 times 0 over square root of 0. Yeah, it will be 0 over 0.
Yeah.
It's undefined. Undefined.
Yes.
So we can't solve this one. We don't know. Since the denominator square root of x minus square root of y approaches 0 as xy tends to 0. We cannot use the quotient rule from experiment. We can't use this rule. First of all, we have to simplify or rationalize this. If we multiply numerator and denominator by square root of x plus square root of y, however, produce an equivalent fraction whose limit we can find. Okay, try to multiply by this expression. So the upper part will be square root x squared minus xy times, and the parenthesis is square root of x plus square root of y. And in this part also, we have this expression. These two expressions gives us x minus y. And in this part also,
Mm-hmm.
if we open, if you open the parentheses, we'll get this expression. Not open. If we take this x outside of the parentheses,
Yes.
if we take this x outside of parentheses, we'll get this expression. Okay, so they are done. X minus y, x minus y.
Mm-hmm.
X times square root of x plus square root of y.
Okay.
I've got this expression. Now we can put 0 here. So 0 times square root of 0 minus square root of 0. The answer is 0. We can cancel the factor x minus y
Yes.
because the at y equals to x, of which x minus y is 0, is not the domain of the function. If it's in the domain of the function, we can't cancel because by the 0. It's not in the domain, so it's easy to cancel this expression.
Uh-huh.
As I said before, it's similar to the functions of single variable to calculate their limits. Now, let's speak some words about the continuity. We're almost done with limits of several variables. We understand the concept,
Mm-hmm.
how to calculate some limits, how to do, what is that. Now about the continuity. As with functions of single variable, continuity had three rules, three steps to check the continuity. The definition says the function f of xy, f of xy, is continuous at the point x0, y0 if, first one, f is defined at x0, y0. F is defined at x0, y0. For
Mm-hmm.
example, f of x, y equals to x over y. For example, this is a function and x0, y0 is x0, y0 is like 1 and 0. The first rule says f is defined at x0, y0. If I put 1 and 0 here, I will get
Mm-hmm.
1 over 0. So is it possible to divide 1 by 0?
It's undefined. No.
Yeah, it's
No. No.
undefined. So it's not defined. The first rule, it fails.
Mm-hmm.
First rule fails. So this first rule says about this one. This rule says about this one.
Mm-hmm.
If it's not like this, if we calculate this one, the first rule will be acceptable and we'll move to the next one. Limit xy tends to x0,
Yes.
y0, f of xy exists. F of xy exists. And then we'll move to calculate this limit. When x tends to 1 and 0, x over y. So 1, it will be 1 by 0. It's also undefined. We can calculate, we can
Yes.
divide 1 by 0. And the third one, this
Mm-hmm.
limit's value and the value of the function must be equal to each other. They must be equal to each other. Only in that case, we can say the function is continuous at
Mm-hmm.
that point. For example, we can check this function at another point, not the 0. Let us choose other point, 1 and 3. So the value
Sweet.
of the function f of 1 and 3 equals to 1 over 3. Okay. Then limit when x and y
It's
tends
possible.
to 1 and 3, x over y is 1 over 3. There it's also calculable. We have got. The
Mm-hmm.
third rule says this together should be equal to each other. The value of function and value of the limit. Are they equal to each other? Yeah, 1 over 3 equals to 1 over
Yes.
3. So we can say the function
Mm-hmm.
f of xy, which is x over y, is continuous at 1 and 3 point. At point 1 and 3. We can say this one. Because we just
Mm-hmm.
check this. Let's write the point
Mm-hmm.
one. Let me write the word point also. At point 1, 3. If you will have this kind of similar questions or exercises in the book or in the homework assignment, check the function for continuity at this point. You have to check like this, step by step, and write the answer in this way. The function is continuous if it is continuous at every point of its domain.
Mm-hmm.
So this word is, you can say the function continuous if it's continuous at every point of its domain. Just now we check the function for continuity at one point, 1 and 3, just one point. If the function is continuous at every point in its domain, if its domain is like this, so we can call the function continuous. We have some examples. Two tests test for non-existence of the limit. If the function f of y has different limits around three different tests in the dominant test, x y equals to 0, y 0, then limit x y x 0, y 0 is not a having the same limit along all straight lines, including x 0, y 0, does not imply a limit exists at x 0, y 0. It's similar with the right side limit, left side limit. If you remember what had the limit, limit x tends to 3 from the left side, f of x, and limit x tends to 3 from the right side, f of x. If you remember, we had this kind of expression for the function of two limits, right side limit, left side limit. For the function of several limits, especially for the function of two limits, we also have this kind of notation. So the function f of x y has different limits for two different types in the dominant as x y equals x 0, y 0. Then this limit is not exists. Burada utilization sería un carácter en la clase que un carácter en la clase de un dato de guarda, un tamaño en la clase de la persona, un tamaño en la clase de tu podría utilizar de Amador, hay una utilization de esta formación de guarda. İşte tamamen içine bir bilmiyordu. Çok tamamen yakınlaştığında ayağına kıyma olarak kıyım olması benim bu dili tartışmaz. Kalau kita akan lihat ada sebuah penambah yang disebutkan nama dia nol zero from that part. If you are the key, of course, the value is different. The value are different. They are not equal. The limit does not exist. Because xy is approached to ay from any part. So this part and this part.
Mm-hmm.
But for the function of single variable, just right side, left side. For the function of several variables, then the several parts. You can approach from there, there. Şimdiden sonra her şeyde böyle yarısı yetinceleri biz de bir kere bana bu son okula bulardı. Bir kere bana böyle bir okula bulardı. Bir kere bana böyle un tamaño de la persona, un tamaño de la persona. La diferencia es kıymet, kıymetini ölçüsünde. Bu kıymetini bir multiple yapacağız. Bir programı kıymetini bitti tamamen 10 ile çarpmaya yaklaşmıyor. 40 ile tamamen yaklaşmıyor. Çünkü burada bitti doğrusuz olmak
Mhm.
değil mi? Koordinatı bilgileri. Koordinatı bilgilerinde bana bu noktayı yok. Yaklaşımı yok. Yani tamamen agar masyarakat isterseniz kıymet kıl olabilen burası. Yok bir alanı. Kıymet. Ini unit multiple. Soon after happened, two times for non-existing activity. By this one, we can
Mhm.
check the existence of non-existing activity. Continuity of components. If f is continuous at x0, y0, and g is a single variable function, continuous at x0, y0, then the component function h is g composed with f defined by h of xy, g of f of xy is continuous at x0. We also learned the composite functions. If you remember, we learned composite functions in high mathematics 1. Some of you, some students read this one as growth, if you remember, right? Growth. It wasn't growth, it's composite
Mhm.
function. G composed by buraklar kimse bize kimse kolay izleyicilerin kendini izliyorlar. İzleyicilerin değişiklikten diye malum çevreden çevreden bunu. Mesela bir agar hep kimse kısmı ilgili olursa izleyiciler ya J böyle özellikle kimse mesela hep kısmı ilgili olursa izleyiciler ve kısmı Şimdi itulah sedang sebenarnya kampanye kimse, buat kimse. Bu düşünceleri hem bir sekolah bende arkadaşlar. Jadi kampanye kimse setiap sebenarnya sekolah açısından kimse ben istiyorum mesela ilk sekolah açısından G istiyor, yine ilk sekolah açısından. Ini kira kira kampanye tersebut, ini ilk sekolah sekolah, jadi ini ini keluar dari mana bukan di composed by F4 itu nanti composed by zero kan mana boleh yang itu saja sebetulnya ini saja agar mana boleh ini sebetulnya nanti dia bisa dilihat itu jelas composed boleh nanti dan boleh ini for example these are composite functions so the functions of three e to the x minus y e to the x minus y continuous at every point x1. This is continuous at every point x1. How to know this one? We have a function x minus y, it's continuous, and we have another function e to the x. So this is f, and it's continuous at x0, y0, and this is g, this is g, this is f. G is single variable function, continuous at x0, x0, y0. So this is g. For this one, we have the y x y over x plus y equals g. It says f is continuous at this point because f is double variable function and g is single variable function. For the third one also, this is logarithm. 7x is g and f will be 1 plus x squared plus g. Functions of more than 2 levels. More than 2 levels. Functions of 3 levels, 4 levels, and more. The definition of general and continuity of functions of 2 levels and includes the limits and continuity of sum, product, quotient, or composites, all except for the functions of 3 or more variables. For example, like this. and then x plus y plus z, or y sine z over x minus y, are continuous throughout their domains. And the limits like this, t tends to 1, 0, negative 1. So this is the sequence. 1 is 1 for x, 0 is for the y, and this negative 1 for the z. You have to plug in these numbers. 1 here instead of just negative 1, 1 and 0. So we have to calculate this expression if we have function of 3 variables. And we will get the answer as a number. Ko'p o'zgaruvchi funksiyalarda ham xuddi shunga o'xshagan holat bo'ladi. Ularni bizga tushuntirib tekshirish yoki limitini hisoblash vaqtida bir o'zgaruvchi, ikki o'zgaruvchi funksiyani ko'rgan qoidalarimiz ishlaydi. Xuddi shunday ishlaydi. Bunda ham agar maxrajdagi ratsionallik bo'lsa, nolga bo'linish holati yoki limit hisoblanmaydigan qanday bir holatlar kuzatilmayotgan bo'lsa, oddiygina qilib x, y, z o'rniga mana shu raqamlarni qo'yib hisoblab qo'yamiz. Berilgan sonlarni x o'rniga 1 qo'yilgan bo'lsa, y o'rniga 0, z o'rniga -1 bo'ladi. Mana shularni qo'yib oddiygina hisoblab qo'yamiz. Agar maxrajda nol bo'lib qolsa yoki boshqa bir limit hisoblanmaydigan holatlar bo'lib qolsa, uni soddalashtirishga, irratsionallikdan qutqarishga urinib ko'ramiz. Mana shunda limit hisoblaydigan holatga kelishi mumkin bo'ladi. So this is the later part of the function of two variables and their limits. And we also have the text side. There are a lot of exercises, examples for you guys. If you are clear with this theory, you can solve the exercise. And we'll continue our practice after a break. Now we may take a break.
Okay.
Nama olsanglar bo'ladi, ozgina bemalol hozir letsiyani deyarli tugatdik. Keyingi orada mana shu ko'rgan misollarimiz, ko'rgan tarix kerakligiga oid misollar ishlatiladi. Ikkitasining o'zini ko'rsatib beraman. Vaqtlar shular bo'lsa yaxshi bo'ladi. Birdaniga gaplashishlar ishlab qoladi.
Mana bu ishlatgan prezentatsiyangizmi, ishlagan prezentatsiyangizni o'chirib olmasdan shuni joylab bering.
Yozuvlari bilanmi?
Ha.
Ipini yechyoribsizlar.
Saqlansa nima qilamiz? Bo'lib qo'yamiz.